Welcome back to another episode of Meta. So again, the point with this course is not to bore you to death with math. And in this episode, we can really go into the math and make you do exercises, but I'm not. I'm going to try and visually show you the meaning of the word scatterplot and how to do correlation coefficients. So let's begin. Awesome. So what is a scatterplot? A scatterplot is a way to arrange data and show a relationship between two variables. Usually, the explanatory variable, which is the cause, is plotted on the x-axis, and the response variable, which is the effect, is shown on the y-axis. So if we think two variables are related, we show the variable which caused whatever to be on the x-axis and the effect of that cause on the y-axis. So let me give you an example. On the left, you can see a scatterplot of weight versus height. And as you can see, and as you guys probably already know, the taller somebody is, the more they weigh, right? It's just how it is, right? Because you have a higher surface area and you tend to weigh more because, there needs to be muscle and fat and all of that to make up that height. So the scatterplot of weight versus height, you can see height is the explanatory variable. It's the cause, right? And that's plotted on the x-axis and the weight is plotted on the y-axis. And as you can see, as the height goes up, so does the weight. As the height goes down, so does the weight. So to interpret a scatterplot, you have to look for an overall pattern, right? You're trying to see these dots, you see these dots and you're like, how can I make a pattern out of these dots, right? So let's take an example here. An age of person, right? And that's plotted on the x-axis. It's the causative factor. And then we look at something like the number of followers on Instagram, which is the effect, right? This is what happened because of the cause. And as you can see, I've taken data of 4 people, right? I've just plotted it on a map. I'm not going to show you what's on the x-axis, what's on the y-axis. Let's just assume there's some numbers there, right? So a correlation coefficient, and in most research papers, this is denoted by the symbol R, is a numerical measure of some type of correlation, meaning a statistical relationship between two variables, right? So the correlation coefficient is a way of summarizing a scatterplot into one single number between -1 and 1. A correlation coefficient of 1 means that for every positive increase in one variable, there's a positive increase of a fixed proportion in the other. For example, shoe sizes go up in perfect correlation with foot length, right? Just like height and weight, the more the length of your foot, the higher your foot size. That's kind of obvious. And it goes up linearly, right? So the higher your foot size, the bigger your shoe size. The lower your foot size, the lower your shoe size, right? It's a very proportional combination. A correlation coefficient of -1 means that for every positive increase in one variable, there's a negative increase of a fixed proportion in the other. For example, the amount of gas in a tank or the amount of petrol in a tank decreases in almost perfect correlation with the speed the car is going at. So the faster you go, the more your tank goes down or the less fuel you have, right? So there's a negative correlation. 0 means that for every increase, there isn't a positive or negative increase. The two variables just aren't related. And that's our job, right? To find out whether they're related or not. And that's the thing, right? Everything we do in statistics is about are two things related to each other in a cause and effect manner. So what we do is we draw a straight line that fits as snugly to the data as possible. So we draw a line that is as close to all of the data, both on top as well as bottom. We're trying to pull the data together. So if you've seen that Captain America scene in the Avengers where, with one hand he's holding the helicopter, in the other hand he's holding the helipad and he's trying to pull it together, that's what the correlation coefficient is supposed to do, right? So how do you find the correlation coefficient? 3 steps. You find something called the fit line, right? Which is you find a line that's very close. Then you find the direction of the slope. Is it positive or is it negative, right? Is the slope going upwards or is the slope going downwards? Then you find the quality of fit, which is what is the snugness of the fit, right? So how do you do it? Step 1, find the fit line. So you find a line that passes closest minimum distance to all of your data points. And again, we're showing you this visually so that you can register in your head how this is working rather than you sitting and doing the math. Almost every textbook I've seen on this first goes through the math, which means you don't understand what you're doing until the very ending, and most people lose interest and just give up on it. So we're trying to teach you what correlation coefficient is visually first. See it. Then what you do is you find the direction of the slope. So if there's a positive correlation, it goes upwards. If there's a negative correlation, it goes downwards. If there's no correlation, it's a straight line, right? So positive, negative, 0. And this is quite easy to do, right? And we know in this case that it's a positive correlation. Then you find the quality of the fit. Which of the two on the left look like they fit more snugly? Is it the first one or the second one? As you can see, it's the second one that fits more snugly, right? It's like Captain America with both those things close together, both the helicopter as well as the helipad close together. Whereas in the first image, they seem far away. The closer they are, the more correlated these variables are. So you can see the first one has a low correlation coefficient of 0.21, and the second one, where the data fits more snugly along the line, has a higher correlation coefficient, which is 0.96. Obviously, the second line fits better. So this is called finding quality of the fit. There is a formula to find the quality of the fit, and that is essentially you check the distances of the point from the y-axis, right? From the y-axis. So if the distances from the y-axis is similar to or lesser than distances from the fit line, then there is a weak correlation. So the formula is very simple. It's the distances from the y-axis divided by distances from the fit line, right? And as you can see, there's a high correlation coefficient here because if the distances from the y-axis is much greater than the distances from the fit line, then strong correlation. The formula is distances from y-axis divided by distances from fit line, which is the same as the previous formula, right? It's the same formula in both places, both for weak and strong correlations. At the end of the day, if I had shown you the formula for this first and never shown you this visually, you would never have gotten it, right? It's a hard concept to understand without first seeing it visually. So as you can see here, the distance from the y-axis are really large and the distances from the fit line are very small, which is why you have a strong correlation, right? You don't need to remember the formula. You can always Google it. The point is, looking at a scatter plot, you can kind of tell how correlated things are, right? So you don't have to sit and put in the formula, but if you want to, the formula is distances from the y-axis divided by distances from the fit line. And as you can see here, big distances from the y-axis, small distance from the fit line. And the previous one, big distance from the y-axis, but also big distances from the fit line, right? So weak correlation, strong correlation, right? And finally, if the distance from the y-axis and distance from the fit line are exactly the same, then your correlation coefficient will be a straight line, which means there's zero correlation between the two variables. And I'm going to attach some resources in the resources section to show you some of these scatter plots with their correlation coefficient. It's important because when you see a lot of these studies, and you see very high correlation coefficients, then you must know that those two variables are very closely related, right? Especially if there's a lot of data. So height and weight, for example, it's very, very closely correlated. Whereas something like the number of hours you sleep and your exam performance, there might be a weak correlation. So whenever you see studies with weak correlations where the author has concluded that yes, these two things are related, be a little skeptical. But whenever you see strong correlations, all you need to do is look at one of those scatter plots. As soon as you see it and you see the fit line and you see that these data points are very close, you should be like, hey, those two things are very closely correlated, right? Maybe they cause each other, right? And that's the entire point of statistics, right? So thanks for joining me on this episode. Catch you on the next.